Welcome to this video on the fundamentals of vehicle cooling systems. We will explore how these systems keep engines running smoothly. This video covers the principles of heat transfer, components of modern cooling systems, system operation, coolant types, and maintenance procedures. In this introduction, we will define what an automotive cooling system is and explain why it is essential for vehicle performance. An automotive cooling system manages engine temperature by transferring heat away from the engine block and releasing it into the atmosphere. The cooling system is vital as it prevents overheating, maintains optimal performance, avoids component failure, improves fuel efficiency, and reduces emissions. To understand cooling, we must look at the three basic principles of heat transfer: conduction, convection, and radiation. Conduction is the transfer of heat directly through solid engine components into the coolant touching them, allowing the system to absorb heat. Convection involves moving heat through a fluid. In a car, this is the coolant or air, which carries heat away from the engine. Radiation is the transfer of heat via electromagnetic waves. While a smaller contributor, it helps the radiator shed heat, especially when the vehicle is stationary. Automotive cooling systems generally fall into two categories: liquid cooling, which is the most common, and air cooling. Liquid cooling systems use a mixture of water and antifreeze that circulates through engine passages to transfer heat to the radiator. Air cooling systems use fins on the engine block to increase surface area for heat dissipation. These are typically found on small engines or older vehicles. A modern liquid cooling system consists of several key components, including the radiator, water pump, thermostat, hoses, and the radiator fan. The radiator serves as the primary heat exchanger, cooling the hot coolant using a core with fins, often made of plastic or aluminum. The water pump is responsible for circulating the coolant throughout the system and is typically powered by a belt or an electric motor. The thermostat is a temperature-controlled valve. It opens and closes to regulate coolant flow, ensuring the engine reaches and maintains its proper operating temperature for maximum efficiency. Coolant, or antifreeze, is typically an ethylene or propylene glycol-based mixture. It is usually mixed 50-50 with water to prevent freezing, boiling, and corrosion within the system. The radiator fan helps pull air through the radiator to improve heat dissipation. Modern vehicles predominantly use electric fans, while older models often featured mechanical ones. Hoses and clamps carry coolant between components. Over time, these hoses are vulnerable to cracking, leaking, or swelling, and clamps may eventually strip or lose tension. The heater core acts as a small radiator inside the cabin. It utilizes hot engine coolant to provide warmth for the vehicle's interior heating system. An overflow or expansion tank is essential for sealed cooling systems. It provides a space to collect, expanding coolant as it heats up, preventing pressure issues. Let's look at how the system works together. Fuel combustion generates heat, which is transferred to the coolant. The pump circulates this to the radiator, where heat is released, with the thermostat managing the flow. There are three primary types of automotive coolants: IAT, which is inorganic additive technology; OAT, or organic acid technology; and HOAT, which is hybrid organic acid technology. IAT is the traditional coolant for older vehicles. It uses silicate and phosphate inhibitors for fast-acting protection, but requires frequent replacement. OAT is a modern, long-life coolant using organic acids instead of traditional inhibitors. It is designed to protect aluminum components in modern engines for many years. HOAT combines the benefits of both OAT and IAT technologies. It offers long-lasting corrosion protection for a variety of metal engine parts and is common in many modern vehicles. Choosing the right coolant is critical, as different formulations are designed for specific materials and engine types. Always check your manufacturer's recommendation. A crucial safety warning: never mix incompatible coolant types. Doing so can cause clumping and damage your entire cooling system. When diagnosing cooling problems, look for common indicators like persistent overheating, visible coolant leaks, contaminated fluid, or the presence of air pockets in the system. If your engine is overheating, check for low coolant levels, a stuck thermostat, a malfunctioning fan, a blocked radiator, or potential water pump failure. Coolant leaks are a common issue. Key areas to inspect for leaks include radiator hoses, water pump seals, the heater core, and freeze plugs. Coolant contamination can severely compromise performance. Watch for oil or transmission fluid mixing with coolant rust, corrosion, mineral buildup, or using incompatible coolant types. Air pockets in the cooling system can cause erratic temperature readings. This issue is typically resolved by properly bleeding the cooling system. Proper maintenance is essential for longevity. This includes adhering to scheduled maintenance, performing regular inspections, and following best practices for care. Follow a regular schedule. Perform a coolant flush every 2 to 5 years depending on your coolant type. Inspect hoses every 20 to 40,000 kilometers, and always replace the thermostat during major repairs. Your inspection checklist should include monitoring coolant levels, the condition of the radiator cap and hoses, checking for leaks, and testing fan operation and temperature gauge behavior. Best practices include using only manufacturer-approved coolant, keeping radiator fins clean, and never attempting to open a radiator cap while the engine is hot. Safety is paramount. Hot coolant can cause severe burns, and ethylene glycol is highly toxic. Always wear proper personal protective equipment and be aware that cooling fans may start automatically. Now that we have covered the fundamentals, let's move on to an assessment quiz to test your knowledge of cooling system maintenance. Question 1. What is the primary purpose of the thermostat? The answer is B, to control coolant temperature. Question 2. What might cause an engine to overheat? The answer is D, all of the above. Low coolant, a faulty fan, or a blocked radiator. Thank you for watching this video on the fundamentals of vehicle cooling systems. Proper maintenance ensures your vehicle remains reliable and performs at its best.